Okay, so what we're going to be covering today is graphing sine and cosine graphs. Now remember, sine is always the y and cosine is always the x. And I talked to you about this a couple weeks ago, but just kind of reiterating. Let's just take a basic 30, 60, 90 degree triangle, and your radius is 1. So in a unit circle, this is 1/2, and this is root 3 over 2. So if I were to create a 30-degree angle and call this point theta, I would go over root 3 over 2 on the x and then up 1/2. So this location, if I were to draw this triangle out, this coordinate is my x, this coordinate is my y. The reason why it's important is if I were to ask you what is sine of theta, or let's just say sine of 30 degrees. Sine is opposite over hypotenuse, which is 1/2. So if you plug in sine of 30 in your calculator, it's going to spit you out 1/2. What is cosine of 30 degrees? Cosine is adjacent root 3 over 2 over 1, which is just root 3 over 2. So look, sine is always my y number. Cosine, see how it equals root 3 over 2, is always my x. So think of coordinate geometry as cosine is your x and sine is your y. Okay. The reason why that's important is because if I were to ask you on an x, y coordinate plane, this is 1, 0, this is 0, 1, this is -1, 0, and this point right here is 0, -1. What you don't know is I have just created a unit circle, right? With these coordinates. I mean, this circle sucks, but you guys get the picture. I have a unit circle. So no matter where I go on this coordinate, on my radius is always going to equal 1, giving me a triangle. No matter where I go on here, my radius is always going to give me 1, giving me a reference angle to make a right triangle. Okay, the reason why that's important is we're going to stick on these axes now. But now I'm going to draw an xy coordinate plane in terms of radians. 2 pi, pi over 2, pi, and 3 over 2 pi. Okay, so I'm going to create a graph. And this graph is illustrated in the notes that you have as well. So what I'm going to do is I'm going to do a sine graph right now. So let's say on the x, let's say we're at 0, which would be here. And if I go 90 degrees, I'm at pi over 2. And then if I go 180 degrees, I'm at pi. And then if I were to go 3 pi over 2, back all the way to 2 pi. Okay, now sine is your y coordinate. So if I'm at 0 right here, what's my y coordinate? 0. If I am at pi over 2, what's my y coordinate at pi over 2? Look, 1. If I'm at pi, what is my coordinate? -1. I'm sorry, 0. 0. This is -1, and this is going to be 0 again. Okay, now, if I were to ask you to plot this on a graph, what you would do is I guess I can just do it right here. So I'm going to say this is 0. This is positive 1 on my y. And this is negative 1 on my y. This is called one full rotation, because wouldn't you agree if I start at 0 and I go one full rotation and I end up back at 2 pi? Look, I start at 0 and I go one full rotation and I end up back at 2 pi. I've done one full rotation on a unit circle. So let's do this. This is pi over 2. This is pi. This is 3 over 2 pi. And this is 2 pi. Okay, now let's plot this. This is a sine. This is one full rotation of a sine graph. So y equals sine of theta. At 0, I'm at 0. At pi over 2, I'm at 1. At pi, I'm at 0. At 3 pi over 2, I'm at negative 1, which is down here. And then at 2 pi, back right here, I'm back at 0. So a full rotation of a sine graph looks like this. But what I'm going to do is I'm going to draw this out a little more in depth. Actually, I'll leave it like this right now because you can look at the notes and get a little better view of it. Now, what I'm going to do is I'm going to draw a cosine graph now. Okay, if I were to draw a cosine graph, let's plot this. We're going to start at 0, pi over 2, pi, 3 over 2 pi, and then 2 pi. These are going to be my plots, and let's see where I am. If I start at 0, I'm actually at 1 on my x, because remember, 0 is right here, which is 1 comma 0. If I'm here, what's my x coordinate? 0. If I'm here, what's my x coordinate on pi? Negative 1. If I'm here, what is my x coordinate? 0. And if I'm back here, what is my x coordinate? 1. This is one full rotation on a unit circle. So let's figure out what that graph looks like. And I'm going to graph it the exact same way. This is 1. This is negative 1. Now I have 0, pi over 2, pi, 3 over 2 pi, and then 2 pi. And let's plot this. It's going to look very similar to my sine. Remember my sine looked like this. It went boop, boop, boop. Now I'm going to plot this. At 0, I'm at 1. At pi over 2, I'm at 0. At pi, I'm at negative 1. At 3 pi over 2, I'm at 0. And at 2 pi, I'm back at 1. So if this was going, it would just repeat. It would repeat every full rotation. It would just repeat. So if you look at the notes, this is how you get the cosine graph. Now, the next set of notes, it's going to talk about the domain. The domain is all real numbers because this can go infinitely to the left and to the right. The range on a y equals cosine or a sine of theta graph is just 1 to negative 1. That's it. It just goes up to 1 and then down to negative 1. The maximum value is 1. The minimum value is negative 1. You can kind of figure all of that stuff out. The interval is it repeats at one full rotation of 2 pi. Okay, now I'm going to break this down a little more. What you don't know is this. I'm going to draw this cosine, but I'm going to add some invisible things to here. The number in front of this would be an invisible 1, and this is called your amplitude. It's on your notes. This is called your amplitude. That means this is how high and how low it goes. Look, it goes up to 1, down to negative 1. It goes up and down 1 unit. That's it. From the center from the x-axis. This is invisible. This is called your amplitude. Now there's also, to figure out your interval, I'm going to put an invisible parenthesis because you don't really need a parenthesis because you don't have any other numbers here, but we can go ahead and put one. And I'm going to put an invisible 1 in front of this theta because there's an invisible 1 in front of it. This is how you figure out your period. The formula is, this 1 is called your b. The formula to figure out your period is 2 pi over b. If I plug a 1 in, 2 pi over 1 is 2 pi. That's my period. This will all make sense as we do some questions. And this is going to be a minus 0 because there's not a phase shift. Remember, whenever you have a parenthesis, it moves left and right. Technically, I can say this is minus 0 because there's a 0 phase shift. And then I can say plus 0. The 0 up here tells you how much you move the whole graph up or whole graph down, just like a normal graphing any type of a function. But we're going to relate this to these specific graphs now. So look, 1 times cosine is just cosine. 1 times theta is just theta. Theta minus nothing is just theta. Plus nothing is, that's how you get this. But all of these invisible numbers are in here. The reason why that's important is look at the next question. It's asking you to graph the next question, which is y equals 2 times cosine x plus 1, or theta plus 1. Now let me explain to you what this is. What I always do is this. I always draw one full cycle. The number in front of here is your b. You've got to figure out your period because it goes in even increments of 4. And with this, there's an invisible 1 in front of here. So 2 pi over the invisible 1 is equal to 2 pi. That means it repeats every 2 pi radians. So that means this is in the middle, and this is pi over 2, and this is 3 over 2 pi. Okay. Now this is how you figure out your revolution or your increment. It's always in even increments of 4. Now what I'm going to do is I'm going to graph cosine. Remember, if you look, because this is negative 1, this is 1. Here's your original graph. Of a cosine graph. Now what we're going to do is we're going to mess with this a little. Actually, let me draw this down here a little. I'm going to draw this better. So I'm going to say this is 1, 2, 3, negative 1, negative 2, negative 3, and this is going to give me pi over 2. This is pi, this is 3 over 2 pi, and this is 2 pi. Now, your cosine graph is going to look like this. Something like that. Here's your points. Boom, 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 boom. Okay, now what I always do is this. I deal with the amplitude first. That means this amplitude, this amplitude, it doesn't go up to 1, it starts at 2. And that means it doesn't go down to 1, it goes down to 2. And that means these two are going to stay. It's just whatever it goes up or down, it goes down to 2, up to 2, down to 2, boom, up to 2. Okay, this takes care of this now. Now I'm going to graph this with my new points. So these are my new points because the amplitude tells you how much it goes up and down. So here we go. And then I would repeat. So here I am so far. Now what I'm going to do is this. I am going to shift this whole thing. See this +1? This is called a phase shift or a vertical slide. This whole graph is going up 1 unit. And this is going to be my final graph. So this point is going up here. 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 And this point is going up here. And now what I'm going to do is I'm going to draw my new graph, which is pi over 2, pi, 3/2 pi, and 2 pi. This is 1, 2, 3, 1, 2, 3. All right, now I'm just going to plot my new one. At 0, I'm at 3. And at pi over 2, I'm at 1. And at pi, I am at -1. 3 pi over 2, I'm up at 1. And 2 pi, I am up at 3. All right, and this is my graph for this. And it doesn't have to be 100% accurate, but I'm going to ask you to draw like 1 or 2 revolutions. So you could draw 1 positive and 1 negative. It's going to be the same way infinitely. It's going to continue the same pattern infinitely. So this is 1 revolution. Super weird, but it will, the more you do this, the more comfortable you'll get with it. Okay, now let's try the next one. Y equals -3 sine x or theta minus 2. I'm going to graph my normal sine. My period is 2 pi over my b. My b, there's an invisible 1, so 2 pi over 1 is 2 pi. That means it's gonna repeat at every 2 pi. Pi over 2. This is pi. This looks horrible. This looks horrible. Let me do a better one. Pi over 2, pi, 3/2 pi, 2 pi. I'm just going to graph my normal sine graph. This is called my parent function. My parent function is going to look like this. Because I'm going to use these points now with this. You know what a negative does? What a negative does is it takes this and it flips it upside down. So if this was just y equals negative sine x, every point would be opposite. So this point would be here. This point would stay. This point would flip. So here is my y equals negative sine x, because there's an invisible 1. But it's y equals, look, -3 sine x. So that means this is going to go down to 3, up to 3. Here's my new graph. Let me draw this right over here. 1, 2, 3, 1, 2, 3. And we know this is pi over 2 pi, 3 pi over 2, and 2 pi. All right, so here I am, and at pi over 2, I'm down at 3. Now I'm in my x at 3 pi over 2. I'm up to 3 and I'm down. So here is my graph right now. My last thing I'm going to do is I'm going to do a phase shift. I'm going to move each one of these points 2 units down and then graph my new graph, and then I'm done. So this is going to go down 1, 2. 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 And there is my graph. Now, if I were doing one negative increment, what I would do is I would just continue that pattern, and this would be a negative increment. Okay, the very last one that we're going to do is going to be a little more in depth. I'm going to graph y equals actually, you know what? I'm going to leave it like that for today. I think that's it. I think we're done for today. We'll get to the periods a little later.